In the final part of this function section, we're going to discuss the concept of scope. Now, so far we've seen how to create and use variables, and we've seen them in conditional statements as well as functions. But depending on where we define these variables will then impact where we can use them. So let me get your brain ticking for a moment. Suppose we have the following code. We create a variable called num, and we set this equal to 35. I then define a function called func, and inside the body of this function, I create a variable called num, and I set this equal to 100. I then return num. Now, if I were to print what's inside of num, what do you think I'm going to get back as the value? Now, if you're thinking 35, you would be correct, because the only way we can access the num variable inside the function called func is by calling this function. So if I put func with parentheses, you can see I then print 100. Now, the concept of scope rules how variables and names are looked up in your code. And the scope of a name or variable depends on where you place it in your code, as you've just seen in this example. And we can use what is known as the LEGB rule to help us understand how variables are looked up. Now, LEGB stands for local, enclosing, global, and built-in. And this is a way for us to remember the Python scope levels and also the steps that Python follows when resolving names in a program. So let's dive deeper into each of these concepts. Now, local, or what is sometimes called a function scope, relates to the code block of any Python function or lambda expression. So if we're setting variables inside of a function, this is us setting a variable with inside a local scope. So we define a variable inside of a function and it's said to be accessible within the local scope only. So for example, if I delete the variable called num which stores 35 and then just have the function defined, when we try to access num, you can see that we run into a name error, telling us that the name num is not defined. So the variables defined inside of a function will only be visible within that function itself. It's created when we call the function, and it's essentially destroyed after the function's been called. It's not created when the function is defined. The next type of scope is known as enclosing, or sometimes referred to as non-local scope. And this is a special type of scope that only exists for nested functions. Now, we haven't actually covered an example of a nested function, but I'm sure if you put your mind to it, you could do this with the knowledge that you've picked up in the course so far. But let's see an example. Let's suppose we define a function called space. And then we set a variable called word, and we set this equal to enclosing. Inside of the space function, I then define another function, and I therefore put def, and I call this function nested_space. And then I create a function as normal. So inside this function, I can set a variable called word and set this equal to local. So if we take a look at what we've written so far, you can see that we have a function defined inside of another function. Now, if we were to look at the nested function or the inner function in this example, we can see that we have a variable called word. Now, word in this example occupies the local scope. And if we go to the enclosing function, i.e. the function that it's nested within, we can see that we have the same variable set, so we have word, and we've set this equal to enclosing. So if inside the nested function I were to print I came from, and then we plus word, we can then call the nested space function within the original function's code body. Now when I call the space function, i.e. the main function, you can see that we print out I came from local. Now let's think about this. When we call the space function, you can see that we assign the variable word with the string enclosing. We then define another function. Now inside this function, we define a variable called word, and this occupies the local space. So we have a local variable which is set to the string local. And therefore, when we print I came from and then it concatenates word, it first of all looks in the local namespace and it therefore adds local to the end. Now, if I were to comment out the variable definition within the nested function, you can see that when I rerun the space function, we then print out I came from enclosing, because word is no longer defined locally, it's defined within the enclosing function, so it picks it up from there. So first of all, it looks in the local namespace, it then looks within the enclosing function. Now the letter G in LEGB stands for global, and this is sometimes referred to module scope, and it's the topmost scope in a Python program, script, or any module. So this Python scope contains all of the names that you define at the top level of a program, and they are visible everywhere in your code. So if above the function definition of space, we were to also write the variable word and set this equal to global, you can see once again that when I run this code, we still print out I came from enclosing. But if I comment out this variable word in the space function, you can now see when I rerun, we print out I came from global. So we've set a variable called word outside of the functions completely, and because this sits in the global namespace, we're still able to access variables set outside of the functions. So hence why we print I came from global. Now the B in LEGB stands for built-in. And the built-in scope is a special Python scope that's created or loaded when you run a script. So for example, we've used keywords such as list, type, print, and so on, and these are attributes that are built into Python. Now names in this Python scope are also available from everywhere in your code, and it's automatically loaded by Python when you run a program or a script. So to summarize so far, the lifetime of a variable is the period throughout which the variable will exist in memory. And the lifetime of variables inside of a function is only as long as the function executes. They are essentially destroyed once we return from the function. And this is why a function does not remember the value of a variable from its previous calls. So we saw above that when you create a variable inside of a function and try to call that variable outside of a function, you will run into a name error because it will state that that variable is not defined. Now, if we define a variable locally, it will only be accessible by that function itself. If we have a nested function inside of another function, first of all, we'll look in the local namespace. If it doesn't exist, we'll then go up to the enclosing function and check for the variable name in there. If it doesn't exist there, we'll then go up to the global namespace and search for the variable definition there. The global scope variables in Python are visible from everywhere in your code. In the next video, we're going to continue on this topic and take a look at the global keyword, which will enable us to change the definition of a variable that sits in the global scope inside of a function.